introductory part of the plastic, and it was just an introduction for the new concept of the plastic engineering, right? And always it is a much more interesting when you are learning about the new things rather than your regular routine part, right? Because see, there are so many options in such cases to have a career in such fields. And today, you know, the situation in the outside world, mostly the industries are industry or corporate or any of the sector is looking for freshers who are having a good amount of transferable skills, right? So the most important thing is you should have a transferable skills, and that to an updated transferable skills. Okay, I generally reiterate these things many times, because having a good pointer or good marks or good certificates will not make you open up for the hiring purpose. So you should have a quality transferable skills, updated transferable skills. So you should aware about the recent technologies, recent transitions, or else you will be thrown out of the current era. Okay, so you should be always updated with respect to the current technology, and for that you should have a transferable skills. Transferable skills means what industry can take from you. See, in return of that they are paying to you, so in return of that they are expecting that you should or you should be usable to them, right? You should have such skills which can be used by them. Your marks, your pointers, your certificates, your resume is a one time investment that is not going to be usable. What the skills you are having, what the techniques you are having, that are actually going to be used by the hiring person. Okay, so work on that. So what the topic now we are going to study is a very interesting topic, and you will have so many options. See, don't look every time, or every time you should not look after that subject as an a part of your academic part, or your curriculum part. You should look after that particular subject or particular area as an opportunity to be a get skilled in that particular area, opportunity to have any idea for your innovation, for an entrepreneurship, for a business, or for a startup. So you should look after every each and every area in that way. Don't look in a such a way that just you will have to appear for an exam. That is there, but it will be a very least priority. It will be at the bottom. The topmost priority will be what the things you are going to take out from that particular point or particular part. Okay, that is the most important. And if you look after each and everything with that perspective, it will be a really an interesting session. Each and every session will be a really interesting. Okay, so just keep that perspective, keep your minds always open, so that you should be a receptive always. And once you will be receptive, you can grasp easily, and that can be implanted easily in your minds, and which can grow or fruitful outputs you will have out of that. Okay, so today also we are going to look after such a part of the plastic engineering whereby you will have so many opportunities. Okay, I am again repeating, your curriculum or academics will be there at the bottom. The topmost priority will be what you can achieve from that learning part. Okay, so today whatever we are going to see out of that, you will have opportunities to work in corporates in that particular sector. You will have an opportunity to have a business in that particular sector. You will have opportunity to have a startup or the innovation in that particular sector. Okay, because this is a completely a different area. So let's start with the second chapter, really an interesting one, and we'll make it much more interesting, right? So the thing we are going to study is the processing and welding of plastic, right? The if you see the word welding, it will quite different. That is showing that see, welding mostly we came across when there is a metallic parts. Okay, but welding doesn't don't take it as a wordly meaning. Welding, it's simply a joining process. Okay, so the processing and welding, how the plastic parts are processed, and then how these are joined. Okay, so this in the first section of this particular unit, we are going to study about the processing of the plastic by different methods. and then we are going to see about the welding of the plastics. Okay. So as I told, there are so many opportunities out of this particular uh, section that we are going to study. Okay. So just look after this section with that with that perspective, and obviously you will get something out of that which will be good for you. So let's start with the first part of this particular unit, that is the processing of the plastic. And there are so many methods for the processing of the plastic. Out of that, the important one methods which are widely used in the industry nowadays, we are going to see that particular methods, right? So the first is that processing of the plastic. A simple meaning is that how any plastic product is manufactured. Now I need not to explain much more about the plastic products or the applications. So many applications in the last lecture we have discussed. So the first Okay, hold. I think I lost my connectivity. Just 2 minutes. I think there is an issue with the connectivity. Just a minute. In 2 minutes, I'll come back once again. Actually, India is a technically paralyzed country, and first of all, technology should be advanced one. Then only we can go for such type of transactions. Otherwise, it is quite difficult. Just a minute. I'll be back. That's why we failed first time during the demonetization also. We are not ready with the advanced technology setup, and immediately we forced to have the demonetization. Okay. Okay. Share screen. Okay, just am I audible now? Am I audible? Okay, okay, we'll go ahead. We'll go ahead. Right. Okay. So I am on the different screen now. So if you are not getting the screen or my voice in between, just unmute yourself and you can tell to me. Okay. Right. So that we are on this screen. Right. So the processing of the plastic, basically the processing is also differentiated in the two categories based on the properties. Like the first one is the thermoplast and second is the thermoset. Right. Now, in case of thermoplast, as we discussed earlier also, once you will heat that, it will melt, and once you will cool that, it will again solidify, and totally reverse in case of the thermoset. So that there are the different methods. So in case of the first one, that is we have extrusion molding. This one in your right. Okay. So that time it's very different material set machine also in the stick. Obviously, it is going to be different. So I'm going to first, then I'm and the first to be different. Folding and rotation. So and everything. The first that we and first method folding. So folding, uh, the meaning of the we what uh, just inject that subject and the backside. When we push it or change it, uh, that, uh, that pressure that series and will be pushed inside the that's what the that's what the actually injection. Similar kind of operation is for the manufacturing also. So it is sometimes considered because of the product it is but only thing is that right? So okay, so basically I'll just back. These four operations are there basically in the um, this plastic injection part. Hold a minute. The first one is the clamping, second is the injection, third is the cooling, and fourth is the ejection part. Okay, so now with that we'll see actually how the process is going on, and then we'll go ahead with the actual things. Okay, so the first one is a screw type, the screw type injection molding, screw type injection molding. Okay, now if you see this setup, if you see this setup, now this machine look like a complex one, but it is having a very simple and plain operation, right? If you see there is a one hopper. This top setup is called as a hopper, and through which the charge is given. Okay, the charge, meaning of the charge here is simple, that the input in the form of raw plastic, input in the form of raw plastic, and that is given through this where you are observing in a red color, right? Through this it is given. Now this is the screw, this is the screw. If you are observing here, this is the screw, right? And in this screw, this is forced in this direction. Now here is the clamping unit, this is a mold assembly, and obviously the mold assembly is going to change as per the product required, right? Here simply this type of product is there. Operation is a very simple, operation is a very simple. See, in the first part, hello, am I audible? Are you getting the screen and my voice? Okay, go ahead. Right. So this is the clamping unit. Second part is, this is the mold assembly. This is the screw, and this is the hooper for which, through which the raw plastic is given. Okay. Now the raw plastic may be in the form of powder, or maybe in the form of pellets, like your tablets, or maybe in the form of granules. Okay, so this is given in this hooper, and one heater will be there around this screw. There will be an heater which will melt down this raw plastic, and this screw, once it will start rotating, it will force this liquid inside this mold, inside this mold. Okay, see, you know, in the casting also the mold has actually three plate or two plate molds are there, getting it? Okay, so it is not a single assembly, it is a we can separate it. So here also these clamping units are there, these clamping bolts are there, or simply clamps can be used. So one is a fixed part and another is a movable part, and in between that there is a mold cavity, right? So once this liquid will be forced inside this particular open chamber, then that clamp is closed, and outside this there will be a cooling unit. Outside this there will be a cooling unit, and that cooling unit will cool down that particular mold plastic which is in a molten condition, right? So the first part is a clamping. The clamping will be, this mold will be placed inside this clamping unit, and this entire setup will be clamped. Then the second will be an ejection. Ejection will be what? The screw will start rotating. Now there will be a hydraulic attachment, or there will be a motor which will rotate the screw, and the rotation of screw will cause the ejection of the liquid plastic charge into this particular mold. Okay, and the second third will be the cooling. This cooling unit will be around this mold, cooling unit will be around this mold, and after that there will be an ejection. After that there will be ejection. At the time of ejection, what we'll do, this clamping will be removed and parts will be automatically removed. Okay, so there are four steps. The first, clamping. clamping of the mold, the second injection. But before injection, there will be a charge or that raw plastic. Then it will be ejected, then it will be cooled down, and through the ejection pin or ejectors, it will be removed from the mold. Okay, so these are four basic steps. And look at here, some of the sample parts I have shown here. Okay, this is a molded part. See, obviously because of the liquid, that charge of the plastic which is in a liquid state, you will not get exact part. Okay, so this extra material will be there, and by trimming then you can remove that. Exact requirement will be this part. Okay, and this runner and sprue I need not to explain in a detail, because it's manufacturing process. This runner design, sprue design, casting design, mold design, everything we have seen. Okay, mold design obviously we are going to go here also, but time being we are just observing the process. Okay, through this runner and sprue, actually this is for passage of the liquid part, liquid plastic. Okay, so this sprue will be connected to the screw, and the screw will push up the liquid inside this sprue, and this runner will allow the liquid to follow into the cavity, and this cavities will be of this size or this shape. Okay, obviously if you change the part, mold design will be changed, right? And this extra material you can trim it down afterwards, and this final product you will get it. Okay, now ram type, a simple structure. See, here there was a screw for pushing the liquid forward, pushing the liquid plastic forward, and here it is only ram. Similar structure. Here is a hooper at the top, and the ram will push the liquid. It is simply as like an injection. Mold will be as it is, heater will be as it is. Okay, just only in case of ram type, it will, this ram will push the liquid. Okay, and this ram will be attached to the hydraulic attachment, or sometimes pneumatic also, hydraulic or pneumatic, or the motor also. Okay, obviously reciprocating type, and this will push up the charge inside the mold, and it will take the shape as like the mold design. Okay, now, so for better understanding, let's have some videos, you will understand it easily. So diagram will not explain everything. I have just see. Okay, so this is a hooper, this is a screw, or it can be a ram. Okay, understand the setup. Just simple difference. Either it may be a screw or it may be a ram. Obviously, the pushing mechanism will be at the back side, and here will be an heater or heating coil. Okay, which will heat this particular liquid, and as per the shape, this will have the product. Okay. Okay, understand the meaning. Here was in a solid state, or and here it was in a, it is in a liquid state. Okay, see, this is an ejection process. Okay, this is the ejection pin, and this is the removable type mold. Okay. Okay, so simple. I may have another one also. Okay, this is for blow. This is for blow, right? So a simple, just here in case of screw there will be a ram, and in case of screw type here will be a screw. Okay, pushing the liquid inside this particular mold through this opening or orifice by using screw or ram. If it is a screw, it will be a screw type. If it is a ram, it will be a ram type. Okay, now you will understand the advantage and disadvantage also easily. See, there is no any complication in this process. You change the mold design, you will get the part accordingly. But see, here, if you see this part, we cannot have a thick wall thickness. Wall thickness, we cannot go for a more wall thickness. There should be a thin part. Complexity we can manage, but it should be a thin part. If we go for more thicker part or large wall thickness part, this mold design will be a quite large. Okay, and again, what is the problem? See, if thickness will be a more, when this liquid plastic will enter in this mold, till it will fill entire section, it will start cooling down and it will settle down immediately. Okay, so that is the problem. So flowability should be a good if your wall thickness is going to be a more. Okay, simple parts with the less wall thickness we can manufacture very easily. Okay, now so many applications like cups, small thickness containers, housings. See, mostly the housings are made from this particular machine or the particular process, because see, housing doesn't require housing or casing. Okay, if you see the mixer casing, right, any type of casing required, that is made from this particular through this process, because housing doesn't require more wall thickness, simple and no more complex features. Housings, handles, plumbings and fittings. Okay, so these types of parts can be easily manufactured through this. Okay, high rate of production, a very high rate of production, because see, as you will increase the screw motion, it will immediately push up the liquid very fastly, and more number of parts you can get it easily. Okay, close tolerances, all thickness is already a very less, so having a more tolerances is a quite difficult. Okay, not required that much. So close tolerances, because wall thickness is a very less, so that you can maintain the close tolerance. Minimum wastage, you may have seen here, less wastage. If you see this extra material, it will be just because of this mold design also. So if your mold design will be proper, this also can be reduced. So wastage will be a very less, and complex geometry can be produced, but there are some limitations. Now, higher tooling cost and setup cost, major issue. Now see the structure, screw, mold design, and this entire setup. The machine will be required to push up the screw, machine will be required to push up the ram. This entire setup will have a huge tooling cost. But this is a one time setup, obviously, but the initial cost is a very high. Obviously, this heating element is also will be there. So the major disadvantage, there is only one, that is a cost of the machine is going to be more. It may be a screw type or it may be a ram type, but the cost will be more. But whenever you are having a bulk production, you can go for this, and less variation of the parts. Okay, second one, again the most widely used, more than injection, this is called as the extrusion molding, the most widely used process, the extrusion molding. Okay, similar as like injection, only the pushing of the plastic will be a different, in a different way. Okay, example I have given, simple to understand, squeezing of toothpaste from the tooth tube. You know how we are doing it, squeezing of toothpaste from the tube. See, it is as simple as that. That is, the process is called as actually a squeezing process or extrusion process. What is happening there? You are just pushing or pressing that toothpaste tube, and the toothpaste is coming out in the form of barrel. See, because it is in a semi liquid state or semi solid state, the solidification level is quite more, sorry, liquidification level is quite more, so that it is not coming directly in the form of barrel. But if you see it, if you push it forcibly, it will come out in the form of barrel, right? Why it is coming in the form of barrel? Because whatever that orifice is there, toothpaste opening, if you see the toothpaste opening, that toothpaste opening is in the form of an simple circle like opening, so that it is coming out in the form of barrel. Okay, so this is a simple example of extrusion molding. Okay, now there are two different types depending on the extruder. There is the first one is a melt extruder and second is a plasticizing extruder. Okay, melt in the sense it only pushes the molten plastic, and in case of plasticizing it is pushing the solidified plastic also. Only basic difference, a molten plastic will be extruded here and solidified plastic will be extruded here in case of plasticizing extruder. Okay, only molten and only plasticized or the solid plastic particles. Now these are some quite simple processes. Solid extrusion means what? Extrusion of solid bars. Only change the shape of the die, you will get it. Hollow extrusion means what? Like pipes and tubes. What you will require, only that opening or die will be a different. And co-extrusion means what? It will be a solid or hollow extrusion, but parallelly there are going to be 2 to 3 openings, and at a time the liquid will come out of that opening parallelly. Okay, so solid like a solid bar, hollow like a bottles or pipes, and co-extrusion means it may be solid or hollow, just multiple openings will be there. Let's see here. Okay, it looks like a screw. Now simple, very easy. See, this entire setup is like your toothpaste. This entire setup is like a toothpaste pouch and this opening. Okay, so a simple, this hooper will be there, it will disseminate the plastic charge inside this barrel. Heating coil will be there around this barrel, heating coil will be there around this barrel, and which will liquidify this plastic, and it will push up through this opening. See, die or opening, similar way, die or opening, getting it? So you change the shape of this particular opening, accordingly you will get the product. Okay, if the die will be simple, a plain circular opening, it will be a solid product, solid bar like product. If the die will be having a small, a pin like extruder in between, it will be a pipe. Okay, so setup is simple. This motor and gear reducer box is required to rotate this screw. You can use here ram also, no problem, ram or screw. Okay, but only issue is that ram is having only one surface which is moving forward and backward, right? But in case of barrel, there is a continuous movement. Are you observing? There is a continuous movement. So uniformity can be maintained. That is the advantage of screw. That is the uniformity can be maintained. Okay. So that screw is mostly preferred as compared to the ram. Now, if you check here, no any complex setup. Simply a screw, hooper, and simple die. Simple die, screw, and hooper. So that costing will be less. So that it is preferred more than ejection, right? But disadvantage is that more complex shapes cannot be produced. Simple pipes and bars and bottles that can be easily manufactured. Okay, simple setup. Here is the process in detail. Okay, and now it is a segregated in this way. Actual setup is this one only, first one, extruder. That is called as the extrusion process. Remaining part is cooling and rolling and this winding. Hooper, it will push up the plastic charge inside this. There will be a heater around this particular thing. This heater will liquidify this plastic and which will be pushed through this opening. Now this is a simple opening. Okay, it will come out as like a pipe like structure which will pass through this water tank, which will solidify that particular pipe. Okay, and this roller will give you the exact shape. Okay, not shape, but it will get it in a proper direction, and this is a winding. Okay, if you see this setup, you will immediately get an idea how the drip pipes, okay, what we call it as a drip pipes, black colored pipes, or your gardening pipes, the pipes that you are using for watering purpose in a garden, that flexible pipes. Okay, That spraying the water you are using, that pipes, that type of pipes are manufactured by this way. Simple. Okay, because winding will be here, it will be, directional movement will be here, cooling will be here, and extrusion will be here. So any cross section can be easily produced very fast, less costly, less cooling cost. Okay, but here is a disadvantage. Products like bars, rods, channels, pipes, only this can be produced. Okay, now see, we'll have good. Where is that? Okay, just see it now. Quite local video, but interesting one. It will explain everything. Okay, this is a local setup, local unit. But see, you will see here extruder. Sorry, hooper. And this is the extruder. This is the extruder. And if you see, here is a cooling tank. Are you observing this pipe which is dropping the water continuously? Okay. And here is the only setup. This screw type setup, hooper. Okay. Now you will understand each and every process here properly. Check out. Okay, this is like a roller which is giving the proper shape. If we, right, okay, see here, what is this, what is this, this is a raw plastic. See, now what is actually happening, if you are observing this at the back side, see, the cursor is showing you this back side, these are recyclable plastic pipes, and this is a waste. This waste is first crushed into the machine, and this type of small plastic particles are prepared. Okay, and these plastic particles are again reused for the manufacturing of plastic, so it is a reusable type. Okay, so you can call this as a plastic particles. If there will be any any other different particles, it is removing. Here are porous screen is there. Sand particles, if there will be, then it will be removed through the screening. It's simply a filtering. You can call this as a granules also. Granules. Actually, the granule shape is different, but you may call this also. Okay. Okay. Whenever you are having a proper granules, then only you will get the uniformities. Now, this is the process of making the granules. First of all, raw plastic is crushed down. Okay. Then it is filtered. That process we have seen. Now, how pellets are made, you will get here. Okay. This is a powdering process. Okay. This will crush down. This is only a simply crushing process. This will crush down and it will make it in the powder form, because all the if you have seen the that breaking parts, it were in a different size and shapes, so obviously it is required to make it in a powder form. It's simply a crushing. Okay, check here now. Check here properly. This is called as a granule making machine. Are you getting how it is operating? See, this plastic powder is coming out of this extruder. This is also extruder. This is also extruder. Okay, and there are so many openings. There are so many openings. You can call it this as a co-extrusion. Just now we have seen co-extrusion. So many openings, and here is a cutter which is cutting this particular plastic into small granules, equal size of granules. Check out. Are you observing? At the bottom, equal size granules are there. Even you can set up this much also. You can have this much setup only, and you can sell these granules. There are so many companies we are only collecting the plastic from garbage, and then they are processing like this way, and you can sell the plastic granules. This here, just look at the cursor. Here is a heater coil, heating coil, which is heating that powder, plastic powder. See, equal sized granules, equal sized granules. Getting it? Here is the hooper, here is the hooper, and here is the extruder. But this extruder is used to make the raw plastic granules. Here is the machine. So here is the motor which is moving the screw. In this hooper, this, look at there, this powder is given here, and these are the final products. Now just see how these pipes are made. Now here is the actual extrusion process. These rollers will not allow it to bend, okay, so that it is required. Cooling unit. Hooper, at the backside motor which will rotate this spindle and the screw inside this particular extruder. Now check out, here are the granules, not the powder. See the shape, equal sized granules. Are you getting equal sized granules? So that first powder is converted into granule, and then granules into product. There is no any such complication in this process. Just heat it, liquidify, put it into mold, and you will get the product. These are the thermocouples, okay, which will heat the plastic inside this extruder. Getting it? Cooling unit. This pipe is coming out of this particular extruder. Okay, I think this is a blow. Let's see. There are granules. Okay, these are the pilots which are okay. This is the machine. Okay, this is a simply injection process. Okay, this is the injection molding. Okay, what I told in the injection molding, wall thickness is going to be quite less, so that these are the products. Cups, caps, small wall thickness. This is different process. Okay, this is blow molding. Don't go for this. This is blow molding. Extrusion molding. Okay, here pipes manufacturing through the extrusion molding. Okay, so let's come back. Right, so it was and extrusion process, and the this was the extrusion and this was the injection. Okay, got it. Now through video you may have understood easily. Okay, simple process, a simple setup, a screw or ram, and pushing it inside the mold. And here in case of extrusion also similar way, screw or ram, pushing it inside the mold. Okay, just only as per the setup, the products are going to be different. Products are going to be different, right? So how much time? 11:57. Okay, so one more process will or we'll cover it in the next lecture. We'll have one more lecture in the afternoon. So we'll stop here, and in the next lecture we'll go for the calendaring and the blow molding. That is also a very interesting part. So we'll stop here for this session. Yes. Okay. Sunil has started putting the attendance also. Okay, no problem. Just put up your roll numbers in the chat box, and thank you so much. You can log out. Be present for the next lecture also. It will be in the afternoon. We'll have that session also, much more interesting.